Hello everyone, myself Pushpalata. Today we'll be discussing about microcontroller concepts of 8051. The pin diagram of 8051 is shown in the picture. 8051 is a 40 pin dual inline package IC. Out of the 40 pin, it comprises of 4 ports. Each port is of 8 bits connecting to 8 pins of 8051. The pin number starting from 39 to pin number configuring from 32 to 39. 32 to 39 is considered to be the port 0, and pin number starting from 21 to 28, they constitutes port 1, and the pin number starting from 1 to 8, this constitutes port 1, and pin number starting from 10 to 17, this is considered to be the port 3. Apart from all these port pins, each ports will be discussed in deeper. They are addressable for input-output operations. We have a pin, that is reset pin, in the 9th pin of a microcontroller, and we have the external 1 and external 2 at the 18th and 19th pin of 8051. The ground connection is provided at pin number 20, and power supply VCC of 5 volts is provided at the pin number 40. For control operations of the memory, external memory, we have EA bar pin which is connected at pin number 31, and ALE and program bar at 30, and PSEN bar at 29. Now the port pins of P3 are multi-addressable. We can make use of either for input-output operations or for additional special purpose operations, and port 0 and port 2 pins are considered to be for addressing the input-output operation, also can be used for address and data transfer to the external memories. Now let us consider the block diagram of 8051. It comprises of interrupt control. It is having external interrupt as well as the internal interrupts. The 8051 comprises majorly, it is CPU, which is being supplied with the internal crystal oscillator, which generates the oscillations and supplies the clock frequency. In addition to that, we have inbuilt 4 kilobytes of ROM, 128 bytes of RAM, and 2 timers or counters. We have serial port connected to the transfer and receive of the data serially. We have I-bar of ports. There are 4 ports which are nothing but P0, P2, P1 and P3. We have different bus control structure to analyze the address, data and control bus in the 8051. 8051 memory organization is shown in the picture. It comprises of internal code memory which we call it as internal ROM or EEPROM. 4 kilobytes of ROM is utilized. External data memory is up to extended 64 kilobytes, and we can connect external code memory or ROM of up to 64 kilobytes. And when we talk about the internal data memory, that is RAM, internal RAM, it is of total 128 bytes of internal RAM, where we have dedicated 32 bytes for 4 register banks, R0 register bank 0 to bank 3, and each bank is of having the registers R0 to R7. Next, we have 16 bytes of bit addressable RAM memory location starting from the address 020 to 2F. We also have 80 bytes of general purpose RAM starting with the address of 30 up to 7F. Above 80 to FF, all the registers of the internal RAM are meant for special function registers. So there are total 128 bytes of internal RAM data memory. Now, in connection with the pin description of 8051, 8051 family members can be many. To be specific, there are a lot of examples of 8051 family members: 8751, 89C51, 89C52, and 8031, and many. All have this 8051 is having a 40 pin dedicated for various functions such as input output, read and write, to address data and also the interrupts. And 8051 microcontroller comes in different packages such as DIP, QFP, and LLC. DIP is nothing but dual in-line package. QFP is quad flat package, and LLC is leadless chip carrier. In 8051, what we study, we make use of 40 pin DIP, that is dual in-line package. Some companies also provide 8051 for 20 pin version also, where we are getting a reduced number of I/O ports because the less demanding applications and the features would be less in case of 20 pin version of the 8051. So depending on the application and depending on the need, we make use of the number of pins in 8051. Let us talk about the pin description in deeper. The pin 18 and 19 of 8051 is connected to external 1 and external 2. The 8051 is having on-chip oscillator, but it requires an external crystal to run. So we make use of a quartz crystal oscillator which is connected to the pin number 19 and pin number 18, which generates the pulses or clock frequency. And in supporting to that, to store, we make use of, along with the quartz crystal oscillator, it also requires two capacitors, each is of 30 picofarad. Let us consider the structure of the on-chip oscillator. As we all aware of it, the pin number 18 and pin number 19 are dedicated for external 1 and external 2, which is connected to a crystal, external crystal, to generate the oscillations, attached with two capacitors, and there is a connection to the ground which try to store and restore the energy. When we talk about the oscillations, here in 8051, it makes use of 12 megahertz of crystal oscillator, but the family of 8051 may comprises of starting from 1 megahertz up to 16 megahertz of crystal oscillator. It depends on the manufacturers, they make available for different 8051 designs. Now the minimum frequencies, which implies that some internal memories are dynamic and must always operate above a minimum frequency, otherwise data will be lost. Now when we talk about the basic clock frequency of 8051, approximately we consider to be 12 megahertz. Exactly it is 11.0592 megahertz. Okay, so the oscillator circuit and the timing is shown in the picture. When we talk about the oscillator timing, the clock frequency F, that is the oscillator frequency F, this is going to establish a smallest interval of time within the microcontroller, which we call it as a pulse. The smallest time interval. Okay, so it is called as a pulse. Now, the smallest time interval we use to accomplish any simple instruction, you call it as a machine cycle. Okay, we are talking about one machine cycle. It is the time taken by the microcontroller to execute one simple instruction. Each machine cycle comprises of 6 states. Each state is having 2 clock periods. So 2 oscillator pulses define one state. Then one machine cycle requires how many oscillator periods? That is 12, which is nothing but 6 into 2 oscillator periods would become 12. Okay, so one machine cycle requires 12 oscillator pulses, which is the minimum time required to execute one instruction. Now, to calculate the time of any particular instruction which we execute, it requires, I have to find the number of cycles C, and the time to execute that instruction is then found by multiplying C by 12. Finally, we are going to calculate the time period, which is divided by the crystal oscillator frequency. So let me write T is nothing but the time taken to execute one instruction, which requires, I need to find the number of cycles which is used for one instruction into 12 divided by the crystal frequency. Because for one machine cycle, it is having 12 oscillator pulses. For n number of machine cycle or C number of machine cycles, we require C into 12 oscillator pulses. It is divided by the total crystal frequency of the 8051 microcontroller. So T is the time which is time required to execute one instruction is equal to C into 12 divided by the crystal frequency. Say for example, if at all I have a crystal frequency of 16 megahertz, then the time taken to execute an instruction, consider I have an instruction which is nothing but add A, R1. Consider if at all one cycle instruction, if this is a one cycle instruction, then time taken to execute this instruction would be 1 into 12 divided by 11.0592 megahertz. If you try to calculate, it would be approximately 0.75 microseconds. Okay, so since 11.0592 megahertz crystal, it seems like an odd value, it yields a cycle frequency of approximately 921.6 kilohertz, which can be divided evenly by the standard communication baud rates. We have various baud rates. To name few, 9600, 4800, etc., which we will be discussing in the later section. Now here, to talk about the timing of execution of one instruction, it is given by C into 12 divided by crystal frequency. So this is about the Xtal 1 and Xtal 2. If we make use of frequency source other than the crystal oscillator, such as TTL oscillator, it will be connected to external 1 and external 2 is left unconnected. So I repeat, if at all I make use of any other oscillator apart from the crystal oscillator, I make use of only external 1, external 2 is unconnected. So this is the representation where you are not giving any connection to external 2 and we directly connect the external oscillator signal to the external one. So this is how we supply the external oscillator clock frequency to the 8051. Let us talk about the reset pin of 8051. Reset pin is an input and is active high. Whenever you apply a high pulse on this reset, then the microcontroller will automatically reset and it will end all those activities which is in execution. So this is often considered as power on reset. Whenever you turn off and switch it on, then your microcontroller will enter into a reset mode and it will restart. So activating this power on reset, it will cause all the values in the registers to be lost. So by default, the register contents will be erased and it is loading the value of 0 in all the registers. So reset is terminating or ending all the executions at that moment and starts from the beginning. Now when reset happens in 8051, as I told you, the registers will be loaded with 0 values and the program, let me consider few of the registers, important registers. Program counter is loaded with 0, DPTR will be loaded with 0, accumulator program status word will be loaded with 0 and by default the stack pointer will be loaded with the value called 07H. That is the default value of stack pointer loaded. B register is loaded with 0. Ports will be made FF because making FF by default ports will be acting as an output port. So you need to, if at all we want to make use of ports as input port, we need to program it. So these are the actions which takes place when we perform reset operation, or pressing the reset pin of 8051 would result in default register value storage with 0 and stack pointer with 07. We have in the pin description one more pin which we call it as EA bar. EA bar is nothing but external access. Whenever I make use of this pin, it is an input pin and which must be connected to VCC or ground. So depending on the pin usage, we make use of EA bar enable or low. When we consider 8051 family members, all the on-chip ROM which is used to store the programs and also have an external code and data memory, they come up with this EA bar pin which is connected to VCC, normally connected to VCC. EA pin must be connected to ground to indicate that the code or data is stored externally. So since it is named as EA bar, I have to connect it to ground such that 0 bar would result 1 and it would indicate that you are accessing the external memory. So the name it is called as external access. Let us talk about the next pin configurations of 8051, PSEN bar and ALE. Program store enable is an output pin. This pin is basically connected to OE pin of the external memory. Now whenever I want to use the external code memory, I'll make PSEN bar 0. So PSEN bar 0 means it is accessing the code memory. If it is equal to 1, then it is accessing the external data memory. Since we have separate external code memory and data memory of 64 kilobytes each, to access individual memory, we can make use of program store enable bit low or high. And we have an ALE pin which is called as address latch enable pin. It is used for demultiplexing the address and the data, which is utilized by the port 0 and port 2 of 8051.